Fellow and Chief Scientist on Smart Transportation in Didi Chuxing, China. When he was with Didi, he established and led the urban transportation business unit. We are very honored to have Dr. Peng join us as well. Dr. Peng is a professor at the Department of Mechanical Engineering at the University of Michigan in Ann Arbor. He currently serves as the director of Mcity, which studies connected and autonomous vehicle technologies and promotes their deployment. His research interests include adaptive control and optimal control, with emphasis on their applications to vehicle and transportation systems. His current research focuses include design and control of electrified vehicle and connected automated vehicles. Dr. Peng received his PhD in mechanical engineering from the University of California, Berkeley in 1992, and has been an active SAE Fellow and ASME Fellow since. Again, we are very grateful and honored to have you on the panel discussion today. And without further ado, I'm going to turn the microphone to our moderator, Bruce, today, so that we can start the panel discussion.
Thank you very much, Yunli. Today we're going to be talking about the smart car. Now, depending on when you were born, the smart car meant different things. For the World War II generation, it might have been automatic transmission, power brakes, power steering, air conditioning. These are things that they were probably invented before this time, but really come to the fore, and it was more available to different vehicles. If you were a baby boomer, it was probably FM radio and 8-track and cassette tape players, cruise control, and seatbelts. And for Generation X, it was CD players, iPods that connected to the vehicle, airbags, electric windows in large quantities, and OnStar, the first connected car technology. If you're a millennial, it might have been a smart key, Bluetooth integration with your cell phone. And for Gen Z, the students who are now in their 20s, backup cameras, GPS, automatic parking, Wi-Fi hotspots, advanced driver systems. These are some of the technologies that have come to the fore over many decades. And it varied depending on when you were born, when you thought was very cool, very cool smart car. Now today we're going to discuss current and future the smart car, and talk about some of the challenges and opportunities that come with the new technologies that are in development. Now, our focus is not on companies developing these technologies, but how the role of the driver is dramatically changing, and how people in these smart vehicles will adjust to how the vehicle will support them and eventually take over driving for them. Notice that when I describe some of the more major smart car technology advances, there's a combination of convenience, comfort, and safety technologies. This is a common theme in the discussion of smart cars, distinguishing what defines a smart car. Auto manufacturers and suppliers can focus on either of these domains in developing new technologies, and sometimes they combine them into one technology, such as OnStar that provides emergency contacts as well as concierge services. Much of the safety technologies designed in the past focused on protecting drivers and passengers in accidents, yet we have millions of accidents every year, and in the US, 30 to 40,000 fatalities. Now, to look at these new technologies, we've divided the discussion into 3 parts. The human-machine interface, HMI, the automated vehicle, and the connected vehicle. HMI looks at how humans interact with the vehicle while driving. has the U of M Transportation Research Institute, where I spent most of my career, has a separate department that studies just this topic, looking at issues related to distraction, how to position knobs and screens and heads-up displays, testing how drivers will use new technologies using simulators. Here we're looking at what new convenience and safety technologies are on the market today and what's coming in the near future and how drivers may respond to them. Now, the automated vehicle looks at the current research and progress in partial and fully automated vehicles, and the connected vehicle looks at the safety and convenience aspects of this technology, as well as its role in an automated future. Now, as Huei mentioned, we have three distinguished panelists with us today to discuss these issues. Huei from Honda, Peng from the U of M Mcity program, and Henry Liu from the U of M Center for Connected and Automated Transportation. Welcome to you all. We have a set of questions we prepared for the panelists. They're not going to give presentations, but if you have questions, feel free to submit them. We may not be able to get to them all, but we encourage you to participate. We may add them into our general questions during our session here, or we may get to them at the Q&A at the end of the session. So let's begin. By looking at the human-machine interface, we have some slides here to look at the questions that we're going to be asking. Right, Huei?
That is correct. Would you like to share your screen or you want me to do that?
You can do that.
Okay.
So we'll first be focusing on the human-machine interface. The first question that we want to address is what is the product-wise installation of the automotive HMI solutions in a vehicle? What's in the vehicle today? Sue, you're representing Honda in this panel. How do you feel about what's going on in the HMI solutions in a vehicle?
Well, I would like to take the Honda Level 3 deployment as an example that just went onto the market recently. The HMI include both inside the vehicle and also outside. I think the second part is often overlooked. Inside the vehicle as a Level 3 system, we have a heads-up display and projecting on the windshield, also a display inside the meter, in addition to the audio and the seatbelt vibration. These are used to be able to probably give the driver an indication that it's time to take over. And in addition to that, the HMI, there's a sticker. It's kind of a traditional, you can call it a low-tech approach, but I think it's a very smart way to indicate to other drivers or other road users that are sharing the roadway to tell them this is a vehicle with a highly automated function, so that they may have a different perception or expectation of the vehicle behavior. Just like people maybe wear a uniform when they're walking, then other pedestrians may have a different reaction to that person. And also during the transition from automated driving to requested takeover control, the vehicle also have a honking and emergency blinking lights to indicate to other road users that this vehicle is about to engage into a emergency situation that may stop very soon. So I think that's the production-wise installation, at least for Level 3 vehicles. When we move to Level 4 and Level 5, these will gradually change. But I think Honda made the first step to introduce a highly automated vehicle, fully certified by the government.
You look at, Sue, one of the changes that has taken place in the story of the heads-up display. Heads-up displays were something that actually started out probably around the 90s. And I think Cadillac was one of the first manufacturers to do that. It really didn't catch on. What's different today compared to the past?
Well, I think technology certainly evolved, made the system much more cost effective, and the consumer acceptance is also growing. Like you said, the Gen Z and people are much more receptible to this type of display that's not like the conventional one embedded in meter or the dashboard area.
Mm-hmm. Mm-hmm. Henry or Wei, do you have anything to add on the story of the introduction of these technologies?
Yeah, hi Bruce. So again, thank you, Yongli, for the invitation for the Michigan China Forum. So let me add one more thing. For those of you who are studying at the University of Michigan, or those of you who may be visiting Michigan in the future, I highly encourage all of you to visit the Henry Ford Museum. And when you go there, you'll see a wide collection of cars from more than a century ago. And if you pay close attention, those cars before 1930 may not have brake light, may not have turn signal, in fact. So I think the effort to communicate the state of your car to other road users on the road or to the driver is evolving with time. So brake light, when it's first introduced to cars, it dramatically reduced the accident rate, turn signal, horn, and also then the indication of the vehicle speed, engine temperature, a lot of other information is evolving with time. And soon introduce the new communication, especially when there is a robot driving your car, how that state is communicating with the driver become increasingly important. And Henry Ford Museum is definitely a place. If you are interested in cars, it's a nice place to learn the evolution of those technologies with time.
Yeah, it's definitely one of those things that is really challenging, and we'll be talking about that throughout the morning of how we make the transition from people driving vehicles to the vehicles helping them drive to the vehicles driving themselves. It's going to be a tough one, and we'll be discussing this during the day. Henry, do you have anything you want to add on to this story?
Sure, sure. One thing I would add to this is that also depend upon the purpose of the vehicle or the use of the vehicle. The recent emergence of ride-hailing vehicles and so it's different. The use of these vehicles probably are different with the regular household, regular personal vehicles. So one of the things I realized is the recent development from DD. They have a D1 vehicle, and then if you look at the D1 vehicle, the right hand side in terms of the door versus the left hand side door, they are actually different. One is on the right hand side door, when the passenger coming on and off, they actually have a sliding door, and along the left hand side is regular door. And so depending upon the use of the vehicle, and I think it's the HMI become more versatile in terms of how this being designed and being communicated with the passengers, with the drivers.
Yeah, it's an extremely important issue in the transition, isn't it? Henry, did you have anything you wanted to add to the history of the market?
Sure. One thing I do want to add is I think car history is very, very important. We're talking about smart cars as the main topic of this forum. But we have to look at transportation as a system. So it's not only just cars. And the history of car is actually closely related with the history of infrastructure. So and the use of the car and the infrastructure as well from user perspective. And so if you look at in terms of infrastructure, and one of the very, very important milestone in the US is the national highway systems, the freeways connecting the cities, and that really lead to the rise of really the car industry. And then you also see that the decline of the railway industries, right? So people actually between cities, intercities, people start to drive within a few hundred miles, and then less use in terms of the railroad, and so that actually propelled also the growth of the car industry as well. So and then it also changed in terms of the land use of the cities, and people can work in the city center, and then they can live in the suburbs. And so they're all so car itself is very important, but the infrastructure is also very important associated with the whole transportation ecosystems.
Henry, is that evolution different from what happened in China? How China has developed their system?
I think it's in terms of surface transportation, particularly the personal transportation from car perspective. I feel it's similar. In the last 30, 40 years in China, there's a significant growth in highways and interstate freeway systems as well. One of the main difference probably because in the last 20 years also because the high-speed rail system grows in China.
Right, that is a big difference, I think, between the two countries in that respect for the transportation system.
Sure.
Hey, let's go to the next question, Yumei. What are the advantages and challenges of automotive HMI in the future? Sue, do you want to start us off on this one?
Sure. I think, Bruce, you are probably more expert than I am. My expertise is in connectivity and automation. I think in the future, there's definitely a good need for consumer education to have them have the proper expectation of what the automated system is capable of performing and under what situation that's outside the ODD. That impact the HMI design as well. And also there are HMI for, of course, inside the vehicle, but also HMI for example, first responders. If a automated vehicle get into a situation that may need to be rescued or interrogated, these are also HMIs not traditionally handled with machines. Usually human roll down the window, talk to the police officers.
Yeah.
Now
right.
we have a vehicle without rider or driver possibly, and who's going to engage in that interrogation process? These are also important topic to address in order for a fully automated vehicle to be deployed on the road that's safe to not only its own vehicle riders, drivers, but also to other external road users and sharing the space.
I think it's one of the issues that we're going to keep coming back with over the next.
And that impact the regulation and the policy, which is going to have a large influence on how and when this automated vehicle can deploy. If we cannot have an efficient way to have the police officers, for example, to properly stop a fully automated vehicle, then that deployment, and there's no proper policy to guide that, then I think the deployment talk would be too early.
Well, that's an interesting story. I didn't even think about the getting pulled over by a policeman.
Yeah, the lawyers and the policymakers make a large decision in this country.
Yeah, it's going to be an issue that I think we're going to be discussing for quite a while, I think. Wade or Henry, do you have something you want to add on that?
Yeah, I can add something, Bruce. So I think in the future, I believe the internal HMI will remain competitive. Every company will have their own interpretation of how you communicate with your driver or passenger. For example, some believe in this way of communication, for example, natural language. Others believe that you can use one pedal to control both throttle and brake, like what the Tesla is trying to do. Things like that, heads-up display, and so on and so forth. But the external HMI, the brake light, turn signal, or how you communicate with other cars, other road users, must remain interoperable. All car companies must agree to the same standard. So I think having two different idea of internal, external HMI is important.
Very good. Henry, do you have anything you want to add?
Yeah, I have to admit I'm not a human factor engineer, so my expertise is not in HMI. But I would say in HMI, I think I can see the two main trends in the HMI development. One is AI applications, artificial intelligence applications in HMI, the personal assistance to drivers, to passengers, and things like that, particularly with voice recognition, the gesture recognition, and the driver monitoring, and things like that. So AI application will become more prevalent in the future. I think that's one thing we will see definitely will be increasing. The other thing I think will be significantly impact the HMI is the connectivity. Is cars will be able to talk to other cars and talk to infrastructure, and then talk to personal wearable devices and your cell phones and things like that. And that will change the interaction between the vehicle with the passenger and the drivers as well. So I see these two main trends. One is the AI, the other one is connectivity. It's going to impact HMI significantly.
Bruce, if I could borrow just a few seconds, recognizing Umtree's contribution to what Henry just mentioned, smartphone and vehicle interaction. Honda has conducted a V2P, vehicle to pedestrian research prototype many years ago. And we shot a video at Umtree back then with Jim Sayer helping me to guide the traffic so that we can get the video shooting done at the limited time slot. It's a fascinating technology that the HMI not only warn the driver of a non-line of sight pedestrian coming through V2X communication, but also the smartphone prompts the smartphone users of a potential conflict with a vehicle approaching. And obviously the smartphone user may be distracted. So that HMI is, even though it's outside the vehicle, but can be as essential as the in-vehicle driver warning.
Very good. Now, one of the things that, as I was talking about earlier, is that, and many of the things that we've been focusing on so far early on are the safety issues. How about a comfort and convenience? There's HMI as part of that story as well. What do we see coming down the road about in terms of potential? I know that I think some people would see the whole windshield as a potential opportunity for either projecting videos or any displays. Again, this might be in an automated, completely automated vehicle. We're going down the road here and saying, okay, what happens if the vehicle is completely automated? What ends up happening then? Do you guys see anything having to do with the issue related to convenience and comfort with the future? We'll get to this question next.
So I can make some comments. So Sue may have a lot more to add, but in my opinion, I think comfort, convenience is competitive. It should be left open. The government shouldn't say too much. It's really up to Honda, Shanghai Automotive and so forth, to invent and to compete. There's only one area that is that's coming up. I think it's going to be there will be regulation. It's related to driver monitoring. So there's plenty of evidence that many of the drivers, when they are interacting with the ADAS, advanced driving assistance systems, such as especially Tesla drivers, they believe these vehicles are level 4, level 5, and they do very stupid things. So right now, the U.S. government, DOT, NTSB, NHTSA, are thinking about how to define a set of regulation that is having a more standardized driver monitoring system or performance. This is an area that will not be compromised But right now, I don't think any government in the whole world has any good idea what is the minimum requirement for driver monitoring. However, if you don't know what the driver is doing, whether he's paying or she's paying attention, then it is a big problem.
Right. It's something we've talked about. It's been talked about for many years now. The idea of people being kind of blowing into a tube to see if they're driving with too much alcohol in them, and looking at their eyes to see it, and now most recently what they're looking at their eyes to see whether they're distracted or not. And we're going to get to the distraction story, I think, in just a little bit. But in terms of the comfort and convenience story, is there, Henry, do you see anything happening down the road that, sometimes when I look at all the things that we have available to us in the vehicle already, I go, what could we do differently in the vehicle, and still be a driver, and still pay attention that would be different from what we already have?
Oh, I don't have much to add. I agree with Huei just said. I think different car manufacturers will have different ideas in terms of how this comfort and leisure, increase comfort and leisure and the convenience to the drivers and passengers. And certainly they will be competing. Different type of technology will be competing in terms of the attention of the drivers and passengers as well. And so I think your next question related with distraction and that become an important problem.
Yeah. Now let's go to the next question, Yumi. Now, as we've been talking about, the industry is in the process of introducing ADAS systems, the automated driver assistance systems that warn drivers of dangerous situations. And some newer systems are actively mitigating dangerous situations through steering and braking. How are drivers responding to these new technologies? I think Huei, your research has been working in that area, right?
Some. So Mcity focus more on the level 4, but certainly we are monitoring level 1, level 2 carefully. So I will say definitely people have been trying to understand whether the autonomous emergency braking or adaptive cruise control, forward collision warning, how are they affecting safety? Safety is the most important metric to measure the performance of these vehicles, right? So there are plenty of evidence, especially more recently, IIHS Insurance Institute of Highway Safety. So they have been doing some very quantitative study of the effect of ADAS, and the effect is very clear. It's statistically significant, up to maybe 60–70% improvement in terms of safety. So I think the importance of ADAS is they need to cover a very wide range of drivers, right? Human drivers are very different, and ADAS need to work very consistently, being a guardian to make sure that the human drivers don't hurt themselves. So, and there's plenty of evidence that no matter how people drive and whether they become more distracted because you have more ADAS, overall the safety performance seems to be improving. So that's the good news.
Hu, how are you? How is your company dealing with the introduction of these new technologies?
Well, I want to tie Umtree again. About 20 years ago, Umtree conducted a fully integrated ADAS system field operational research called IVBSS, and Honda contributed with our engineering support to, I think, 16 or 20 Honda Accord vehicles. And of course, we see a significant positive impact on the safety, but also how the drivers, Umtree monitors the driver with the full data acquisition system to see the most effective is the audio, and of course, and followed by the visual. Those research really have a large impact to researchers like us to refine our existing system and also guide our future design. we see this ADAS as one step towards automation. It's not a switch you can turn the knob all of a sudden overnight, you go to level 4 and 5. That is how we approached when we deployed level 3 in Japan. It does have a limited ODD, but at least we passed the government certification that allowed the vehicle driver to be eyes off road. And I think the eyes off is a significant first step that has the government and industry working together to allow such operations. Of course, the HMI is a big part of that as well, to monitor, like Bruce and Henry mentioned earlier, the driver monitoring is a very essential part of it.
Yeah, it's a very challenging story, I think. But I guess for our audience, they may not know what all these technologies are, right? So they have the warning systems, the forward collision warning. I don't know if there is a side collision warning. I think we've talked about that, but I don't know if that's in play. There's what are some of the others, Sue?
Well, the most close to side collision could be blind spot.
Yeah, blind spot
detection. I think the existing sensing technology still have challenge on the cross path warning. That's why the communication system would provide a significant breakthrough by vehicles talking to each other at the blind corner. And those are the most fatal incidents, the T-bone type. Yes. These connectivity can certainly address those collisions. Yeah. But again, if we coming back to the HMI, I think consumer education is very essential for people to have the proper expectation of what the system can or cannot do.
I know that when we talk to people who are buying new vehicles, and it's very inconsistent from dealership to dealership, because usually you're taking possession of the vehicle at a dealership, and there are some stories where people were spending half a day learning about all the different technologies and how to drive, not just to drive their car, but to take advantage of all the different technologies that are in the vehicle. I think this is something that's really, I think is going to have to change dramatically over time. And I think there's opportunities for, either through YouTube and other videos or ways of getting people involved in using their new technologies in their vehicles. And of course, you really don't want to have them go out and testing the forward collision warning system. But then you have the mitigation story, where you have these technologies actually taking over and helping you a bit. If you start moving out of your lane, it's going to start moving you back. If you haven't turned your signal on, if you haven't put your turn signal on, you're going to get moved back into your lane. And of course, drivers are going to have to adjust to this, and some of them may not like it at the beginning. But I think as we've all been talking about, the research that's been done in these areas really shows that it's dramatically supportive of drivers and reducing accidents. And I just know that accidents that I've been in, some of the few accidents that I've been in, if I wish I had a forward mitigation system, where someone slams on their brakes and I took my eyes off the road for just a second, and it would avoid accidents. Obviously, one of the issues that we struggle with, though, had to do with the weather conditions and the kind of clogging up of some of the sensors because of snow and ice, especially in the northern climates. How are they addressing that nowadays? Does any of you have ideas about how they're addressing that?
So that's where the connectivity would significantly help in the situation where cameras may not be able to see as clearly compared to a clear day. The communication is weatherproof, regardless of the weather condition. You can always count on the several 100-meter range of advanced situation awareness. I think Huei and Mcity has done a tremendous job to investigate the benefit of a connectivity, V2X, and also 5G. The recent installation in Mcity probably could be the nation's most advanced infrastructure setup for safety using V2X.
Anything else anybody want to add to this discussion before we move on to the next topic?
I just want to add that as you mentioned IVBSS, we're still using IVBSS data, and then a couple of weeks ago, we're looking at those Honda vehicles, and although these are 15 years of vehicle already, we still utilize some of those.
Thank you.
Henry, what does IVBSS stand for?
Oh, exactly. So what's IVBSS?
I think it's
integrated vehicle-based safety system.
There
Okay,
you
yeah.
go.
Yeah.
We were very proud to be part of it.
And it's something that we worked at Humphrey for long periods of time, and we don't need to get into the advertisement of Humphrey, but because we all know all the work that's being done there, and all the different groups that are doing fantastic work on vehicle safety in particular. Let's go on to our next segment is going to look at the automated vehicle, right? And let's look at our first question. And Huei, I think you're going to tackle this question.
Yes.
You talked a little bit about about L3, L4. Let's get the audience up to speed on what the different levels are.
Absolutely, I'll be happy to help. So usually I will share my screen, which I think some visual is helpful. All right, so okay. I think this is a very nice figure to show the ideas of the different levels of automated vehicles. So it's very, very important to understand that this is a gradual evolutionary toward full automation.
Wait, I'm not seeing your screen.
Are you not seeing my
screen? I'm not
screen?
seeing your screen.
Huh. It shows that I was sharing.
We see a white screen.
You see a white screen?
Yeah, a white screen.
How about, I'll try one more time. No, okay, so I see. So the PowerPoint. Can you see?
There you go.
Yeah.
Okay. Now, so basically today we are at level 0. That's where we are today, and the thinking is that we'll be evolving toward the robot taking over everything. And when some of the functions, especially controlling vehicle speed, controlling the lane position, is done by the robot, we call that co-pilot. Even when the robot is doing both the steering, braking, throttle control, but the humans still need to be in charge, we are at level 2 only. So basically humans still need to pay attention. So it's very important to say that the autopilot from Tesla is level 2, even though Elon Musk will keep telling you it's level 4 and level 5 is just around the corner, next year. He always said that. So, but we, for those of us, I think including Honda, who work on the automated vehicles, we all understand that everybody is striving to move toward level 4, and we are trying to increase the operational design domain of the robot to become bigger and bigger. And we may never really have a level 5 vehicle per se. Let me explain, right? Level 5 means no condition, every driving condition can be handled. That means any weather, any speed, no geofence, so the robot can handle everything. But the truth is, even human drivers, when it snows very hard, when it rains very hard, or there's flooding, you shouldn't drive. So I don't believe in level 5. We always believe we just need to have a large enough operational design domain, a level 4, but it is very important to understand when not to drive, meaning you respect your ODD. So this is the definition of the SAE defined vehicle automation level, from level 0 all the way to level 5.
Very good, thank you. Let's go to the next question, Yumi. So I must admit that was one of the saying that you don't believe in level 5 is there are a lot of people. There may be a lot of people in the audience are pretty shocked by that statement, Huei. Because when you
I'm an engineer. I'm not a salesman.
when people talk about automated vehicles, they talk about driverless vehicles, right? They talk about what and here the next question focuses on what happens in the differences between urban, suburban, and rural. But really, if you really can't get to level 5, you really can't do shared vehicles. Can you?
No, I think it's important. Even DD, that's or Honda, right? When you have a very nice level 4 vehicle, it's very important you understand where not to drive or when not to drive.
Yeah.
When it snows really hard, when it rains very hard, are you sure your camera LiDAR can see clearly? Are you sure you want to drive? So understanding where and when not to drive is very important.
Yeah. But there are whole ecosystems being developed, and people in designing these kind of future systems where they're talking about not having a driver in the driver's seat. And that's really not level 4, that's really level 5, right?
No, I think DD can still say, I am not going to this part of Shanghai or Beijing because there are too many pedestrians, too many bicycle. The unprotected left turn is just too hard for me. It is reasonable. In fact, I have seen some very clear presentation from other companies who basically say, if they have a route, let's say point A to point B, they would choose the route that will avoid a certain segment of the downtown area that they think they cannot handle. It's smart. It's not, it's being brutal and brave is not always smart. Right? If you know you cannot do it, just don't do it.
Right. Of course, there are people who will argue there's always situations where I need to go. I need to do this. I need to go get that soda.
Well, when it snows like 10 inches an hour, do you want to go out? That's the question. Even a human driver should not.
Yeah. And we know many drivers who do that anyhow, right? And they end up creating 100-car pileups sometimes on freeways because they overdrive the capabilities of the vehicle. They don't understand, or they get a whiteout. They get a sudden whiteout on the freeway, and you can't see, and then the road's slick off, and the cars behind them are driving too fast, or the trucks behind them are driving too fast, and they slam into each other, and then you've got I think we had some tremendous I think there was a tremendous pileup in Houston, wasn't it, recently? And I know we've had them in Michigan over probably, I think, was it 4 or 5 years ago. Luckily, we haven't had those for a while, but it does happen. Do you have anything you want to add to this discussion?
I think the Huei touched a good point that we're not salesmen. As an engineer, we are responsible for what we designed, and what the system cannot handle is very important to clearly be communicated to the user. Such as the Honda L3 system, we have extensive explanation to the consumer, but also in the material, we clearly indicate there is stepped warning for the drivers to be able to pay attention back to the vehicle system and the road. And in emergency situation, the vehicle will gradually stop. These are highly automated features that people shouldn't overuse and should understand the constraint. And also on the policy side, the certification process also clearly draw that boundary, what the system can do and cannot do. When it cannot do, that it bear the responsibility of informing the driver. I think some other manufactured system may be causing some misperception of the capability, which is it worth wasting your life if you just want to get that one bottle of soda in a heavy snow day, trusting the system could handle it? There's definitely a consumer expectation that needs to be adjusted.
Henry, do you have anything you want to add to that?
When I see the question related with whether it's urban, rural, or suburban, it's really is the complexity of the driving environment, right? So it doesn't really matter it's the location is in the city center or in suburb center. It's really the complexity of the driving, and that involve two part of it. One is the other road users, the interaction with other road users, the pedestrians, the bicyclists, and other cars and things like that, and make your driving, the complexity of driving different. The other thing is that the static environment, right? The driving environment, whether this is a clear day, or whether this is a 1 lane or 2 lane or intersection, signalized intersection versus stop and things like that. So these are the two things really going to impact the difficulty of driving, and that this will limit your operation design domain. So I think these are probably the main differences.
One of the questions that popped up from the attendees, Henry, was how do V2X communication impact? How does that impact autonomous driving? And when does mass deployment of V2X become possible? Now, we'll be talking about that a little bit in our next set of questions about the connected vehicle. But in terms of the impacts on autonomous driving, what do you see happening there?
One of the things I would say, as you will probably know this better, is connectivity is a sixth sense of the vehicle, right? So it actually adding information from the communication channel, you can the current setup, the vehicles rely upon single vehicle sensors, the onboard sensor. They can detect in terms of other vehicles' position and speed and things like that. And you can also receive that information from the surrounding connected vehicles or connected infrastructure as well. So you basically get one more channel that you can get information you probably won't be able to get otherwise. So I think that's the differences, the main differences, and that information can be utilized for improve, better prediction, better planning, and things like that, so that you can increase the safety.
So let me add to that. So Henry said this is the sixth sense. That's a great analogy of what the communication is. Communication means beyond line of sight is possible. In addition, I think communication also, for control guy, right? I will always say, communication is another sensor, so you can see things beyond line of sight, but also it's a control. You can tell the traffic signal, please hold the green light for me for 5 more seconds so my bus can pass through that intersection, saving 2 minutes. So communication is both a sensor and also possibly a actuator that can make the whole transportation system become a system rather than just individual units.
Yeah, Henry, we'll talk about that a little bit more in the next section. I want to talk a little about that issue of that connectivity and how what are some of the challenges of keeping that vehicle connected to itself and to the other vehicles. Huei, did you have anything you want to add to the urban rural suburban story?
I think the current deployed Honda Level 3 system is for freeway use only. I think for a good reason. As an engineer, we're designing and deploying a system that we have full confidence that will bring safety benefit to the driver. And right now, I think the technology is matured enough to handle freeway traffic. And once we think the situation is no longer suitable for the continued operation, we would warn the driver to take over control gradually. The urban, more complicated scenario certainly is on many automakers' roadmap, but these would be a gradual evolution.
I think what we've been hearing from all of you, it fits in pretty nicely into our next question. Let's see that one, Huei. do drivers trust or rely on AVs? What is the research being conducted on trusting AVs? Anybody want to start off on that one?
I would like to start, Bruce.
Sure.
We have been doing a lot in this area. So let me bring another analogy to the story of the discussion. So imagine you are at the beginning of the 20th century, right? So airplane has been invented. The Wright brothers showed that heavier than air flight is possible. Charles Lindbergh flew across the Atlantic Ocean. But even when, and in World War II, of course, airplanes have been used military in the war a lot. Even after all of this, people are not jumping to a commercial airline and fly on a weekly basis. They don't trust, because if you crash, you die, right? So AV or level 4 vehicles is not as dangerous as flying in the air. However, people are still saying, oh, I'm worried the robot may go crazy. Some people may hack and I can die, right? So trust is usually earned gradually when people have seen the airplane flying, many other people fly, or even the vaccination, right? People have the Pfizer vaccination. There are millions of them having vaccination. None of them die. So maybe I'll go to take it, right? So again, trust is won over time. When people see it regularly for several years, they will become more and more comfortable. They are no longer alien. They are no longer something they totally don't have any idea whether they are safe or not. So again, trust must be won. So we believe government need to play a very important role. Government need to say, I'm the third party. I'll give an impartial verification of the Honda, Toyota, GM's, Shanghai Automotive vehicles, and we give you the same test. And here is what we done with the vehicle. And according to our impartial testing, we think this is they are very capable. Capable doesn't mean they never have any crash. Capable means it's a very impartial verification validation of the design. And hopefully when the car company do their job, government do their job, gradually will won the confidence and trust of the regular drivers.
How long do you think this is going to take, Huei?
When you say take, you mean won the trust?
Yes.
Okay, Charles Lindbergh flew across the Atlantic Ocean to the takeoff of the commercial airlines. It takes a good 40 years. Now,
Yeah.
I hope that ground vehicles, they are on the ground. They are not flying in the air. So hopefully it's shorter time, but it will take some time. Yeah. So when people say, oh, it's just an elevator, right? I ride in an elevator, I never worry. When those vehicles are so common, you see them in Beijing, Shanghai, in Ann Arbor, they become so common, they become just an elevator. You go in, you get to where you want to go. You never think twice.
Right, right. And one of the things that we talk about in the transition is that there are some people who really love to drive, and that the scenario that you're painting of the L4 driver, there's still a driver in L4. In L5 there's no driver. There's not, you don't need a steering wheel, you don't need brakes, brake pad. I mean, not brake, you need brake pads. You don't need a brake pedal or gas pedal, right? And and so there's testing being done on these L5 vehicles right now, right? In San Francisco with Cruise and Waymo and Phoenix. And I'm sure this is going on in China as well. There's the scenario that you're talking about really allows people to continue driving, and the people who really love to drive get to continue to drive and actually be very well assisted in driving, so that they actually make fewer mistakes. We know that obviously when there are millions of accidents, people make mistakes, and it cuts down on a number of those mistakes. Is this the way you're seeing this play out over time?
Is that a question to me?
Yeah, sure, Sue. Anybody can jump in.
Well, I agree with Huei completely. Taking an elevator as an example, in the early days of elevator deployment, even though the engineers are confident that the elevator is very safe to ride, most of the operators choose to have a human in the elevator to operate it just to make sure the riders are comfortable with it. And that lasted for a number of years until people gradually gain the trust and choose to ride it without an operator. I think it's a similar path for fully automated vehicle from ADAS to level 3 with limited ODD and expanding ODD. The riders are more comfortable with it, and then we roll into higher level of automation.
Henry, do you have anything you want to add to that?
Sure. One thing I want to add to that is that related with safety testing, and so if these automated vehicle will be when they are deployed, people's expectation is that they will be have higher safety level performance than human-driven vehicles, right? So if you look at human-driven vehicles, and it's probably 10⁻⁶ in terms of miles for per accident, and on average, and tens of probably power of 8 for a fatal accident. And so if you want to compare with human-driven vehicles in terms of their safety performance, and to achieve such safety performance or safety performance comparison in a statistically significant way, then you're really looking at a large number of miles driven, testing. And so far, none of these automated vehicle developers has logged such number of miles. So it will take a while for them to get to there also. I think so. So it would. This is not only just the I would say consumer confidence. It's also on the developer side, they will need some time to accumulate and to collect the data and then to achieve such a safety performance.
Very good, thank you. I think we're ready to move on to I think we're ready to move on to the next question. Are there any differences in the approaches between the new and established automakers, and sometimes not even automakers, more like tech companies, and the established automakers? And if so, what are those? Again, this is for the automated vehicle.
Well, I'll take a first try of this answering. I think the established, by definition, maybe have a longer history of making vehicles, and the technology companies certainly contributed significantly to push the envelope on how the technology progresses. But I think we should always step back and think of, why are we developing an automated system? What's the number one goal? It should be safety, to reduce fatality towards a collision-free society. That should be the number one goal. Whether you're established or a relatively new tech company, human life is precious. We should always take it very seriously. And that may make each automaker to select a slight different approach and focus. For Honda to deploy a level 3 system that when the rigorous testing, like Henry mentioned earlier, simulation-based on-road testing, the entire domain are fully mapped. Those are, I don't think these should be done differently, whether you're established or you're new. These rigorous design and the discipline involved in deploying a system like this would ensure the safety. And then we can talk about enhancing people's life with maybe more convenience features later on. So to me, we may see some difference, but I think we should align the goal first.
Let me say, sorry, Henry, go ahead.
You go ahead. Go ahead.
Okay, so I think Sue is too nice to say something bad about the tech companies. There are two things that I think there are two different major differences. Number one is most of the OEMs or traditional car companies believe in an evolutionary approach, right? They will develop AEB level 1, level 2. Once they are ready, then they move on to maybe level 4. That's one major difference, but some of the technology companies said, I'll jump to level 4, or they pretend they have a level 4 product already. So that's one major difference. The second is some of the tech companies are like the smartphone kind of developer. They say, make mistake quick, but correct your mistake quick. Car companies, on the other hand, say, no, you cannot use consumers as your beta testers. So that's a major difference too, right? Do you use your customers as beta testers, or you think it's unethical to do that? Of course, one of the reason car companies are more conservative is because they have bigger assets, right? Some of the emerging car companies has a negative asset. And GM and Honda, they have huge asset. They can be sued, $5 million a piece. But Tesla, they don't care, right? They can be sued. They have no assets. So I think there's a fundamental difference in whether you want to make mistake quick and correct them and use consumer as a beta tester, which in the recent NTSB letter to NHTSA, they said this is wrong. You have to correct that. So those are the two major differences, I think.
Henry, do you have something you want to add?
Sure. I wouldn't separate, say, the established company versus new developer. But I think I agree with you and Huei, whoever the company is, they are providing transportation to the users, and safety is the number one problem we need to talk about. And in terms of the development, the technology roadmap, I think I would say I see two schools of thoughts. One is, as we mentioned, is the evolutionary approach from level 2, level 3, gradually evolve into level 4. And the other one is directly attacking level 4. But then for production in the near term, they may utilize level 4 for level 3 or level 2, and then accumulate more data so that they can help them to to develop better level 4 vehicles. And so I see two schools of thoughts. One is going up. One is starting. One is sort of like a bottom-up approach. The other one is sort of like a top-down approach. And so these are very different development roadmap. I see the other major differences in terms of the technology roadmap is really whether this is a single vehicle intelligence versus cooperative driving intelligence, and there's major difference there. There are companies focusing on mainly on a single vehicle intelligence, and then but some of these taking a different approach. They are looking at how you can utilize information from the infrastructure from other vehicles to help them to do cooperative driving to improve safety. So these are, I think, I would say, the second major differences in terms of the technology roadmap.
And since this is the Michigan-China Forum, do you see differences between how the U.S. is approaching automated vehicles and the Chinese?
And I would say, true. I think my perception is in the U.S. Focus on the former one, which is more on single vehicle intelligence. But I think recently U.S. has already started, including Honda. We're working with Honda as well to look at cooperative driving driving automation. And then Federal Highway has CARMA program, and so that's also CDA, cooperative driving automation as well. Although I would say comparatively, the Chinese government invests more on the infrastructure. They emphasize more on cooperative driving approach, and that's true as well.
Yeah. Do you see the car companies and the tech companies approaching it any differently in China?
Again, I wouldn't say separate the tech company versus the established automakers. I think they right now in the space they choose different technology development roadmap, but I think this everybody's trying to achieve the same goal.
Mm-hmm. I know some of our recent research where we've been just kind of tracking the joint ventures and cooperation agreements between the tech companies and the auto companies in China. It's dramatic. It's dramatic. Just within the last 3 or 4 months, the connections between Huawei and the car companies and Baidu and the car companies, it's significant. We're going to be reporting about this probably within the next.
To make, to do a production. And right now offering level 4, I think it's not very realistic. And so they have to go down, you might utilize level 4 for level 3 or level 2. And then from that perspective, then they work with one of the established OEM is their fastest way to do the production. And from the other side, from established OEM perspective, and adding the capability, from automated driving capability from Baidu or other tech companies, they are also the fastest way for them to adding additional values to their existing vehicle models as well. So that's sort of the intersection between these two schools of thoughts.
Okay.
So Bruce, can I also add?
Go ahead, Wei.
Yeah. So I think increasingly companies realize it's either too expensive or too slow for them to do it alone. So that's why alliance to cooperate on automated or electrified vehicles become much more popular. In the past, you wouldn't ever believe that Honda and GM will work together and so on and so forth. But again, it's too expensive or too slow. Now, I would like to answer one of the questions typing. So basically, I think the major difference, again, the evolutionary versus directly level 4. For traditional company, Honda, for example, right? They believe it's safer to do level 1 first and level 2 and level 3 and so forth. And they are making revenue. They are not only making impact to safety already, or they can also be making money so that they can invest on their level 4 research. Some of the companies that have a lot more resources, like Alphabet or Waymo, they could dump billions of dollars into a company directly working on level 4, but OEM, many of them don't have that kind of resource to do it that way. So that's related to the question from Nigar Sultana.
Yeah. Sue, have you any experience with what's going on in China and how they're developing their automated vehicles?
Well, I'm not very familiar with the Chinese situation, but I do want to remind people what happened in China actually have a lot to do with what a great foundation was built in the US. Many of the internet technology, including AI, connectivity, for example, V2X, the dedicated short-range communication, those were Western-born technology that has been worked on for decades. And China certainly benefited from that very solid foundation. I often think of back when China was a world dominant power a few hundred years ago. And the Western also learned a lot from Chinese. What the technology back then, China was high tech. We're talking about campus and agriculture that was hundreds of years BC. Those were pushed the Western to progress, and now it's kind of going on the table. I turn the other way. China is learning a lot from the Western and certainly making a very fast progress. So I see this both are benefiting, and depending on who's learning whom, eventually will merge together.
Okay, very good. And let's lead that. Let us lead into the next question, next section, looking at the connected vehicle. we've been talking about the connected vehicle, but let's focus a little more directly on the issues related to the connected vehicle. How do all vehicles act and interact with each other in a smart city? Henry, we're gonna lean on you for these questions, some of these questions. So why don't you start us off?
Sure. Let me just briefly talk about connected vehicle. So connected vehicle, what we're talking about here is really those are the vehicle has some sort of onboard devices, so what we call OBU, and they can communicate with the other vehicles with equipped OBU as well, and they can also communicate with the roadside unit installed at the infrastructure. So these devices enable them to talk to other vehicles, talk to infrastructures, and in the future talk to pedestrians, bicyclists, and things like that. So that's why in early I said this could be serve as the sixth sense, that you can get more information for the subject vehicle, and then so that they can help you to do a better job in terms of driving. And so to looking at the question asked of how connectivity really impact in terms of interaction, I think I've answered the question by two, I would say two different levels. One is on the macroscopic level. So if you look at macroscopically, connectivity can help you, as I mentioned, can help you in terms of do a better job in terms of driving, and that related with car following, related to lane changing and things like that. And connectivity can also help from macroscopic level perspective, from aggregated level, and that with connectivity, it could increase, it could reduce the vehicle headways, and that lead to higher traffic throughput, and then lead to less queuing, and then and things like that. So if you look at the connectivity can help both on the macroscopic level, on macroscopic level. And the other thing I want to mention is that connectivity also enabled vehicle itself as a mobile sensor. So in the past, when we look at the smart city perspective in terms of traffic management, and we all rely upon infrastructure-based sensors, right? So you see these cameras at the intersection. Essentially, they are counting the number of cars, and then they are utilizing this information for traffic signal management and things like that. But in the future, vehicle itself become mobile sensor, and that mobile sensor will be providing data to traffic management purposes as well. So that's a byproduct, I would say, because of the connectivity, and they will help to improve not only the individual drivers in terms of safety, but this one on a bigger scale from smart city perspective, helping to improve the efficiency and sustainability of the whole system.
Now, Henry, when we talk about the connected vehicle, we're talking about vehicle to vehicle, but we're also talking about vehicle to infrastructure.
Mm-hmm. Yeah.
How big is the cost involved in setting up the infrastructure needed in across the country, or at least starting small within cities?
Yeah, so in terms of these OBUs and RSUs, is really depending upon the production volume, right? So right now it's still expensive, but because the volume of production is very small at the moment. So once this become mass production, either on the vehicle side or on the infrastructure side, I think the cost will dramatically be reduced.
5G or DSRC?
5G or DSRC. Huei probably know, the can comment on that also. But there was, U.S. has been working on DRSRC 20 plus years ago, right? So this has a long history of DRSRC, and then in 2014 there was a proposal rulemaking already at the time, but although it was not not become a mandate. And then last year, FCC has a new ruling which essentially gave out the 75 megahertz of safety band to other use of to other use of the communication, right? But that's not it's not on the Federal Register yet, and it's not a mandate. So there's still I would say argument between from the US DOT perspective versus from FCC. So it's still uncertain. I would say that's still uncertain whether this is entirely cellular or 5G or versus DRSRC. Although I would say in China, it's already determined it's going to be CV2X. It's not going to be DRSRC.
You said in China it's going to be.
It's going to be cellular V2X. It's not going to be DRSRC. Yeah. In China.
And for our audience, digital short range communication is the DSRC story. Wei, do you want to say something about this?
Oh yeah, so a little bit. So Henry gave a very good background. So I just want to say all three of us have worked on DSRC related technical challenges for many years. We have a special, there is a special place in our heart, DSRC, but it looks like the spectrum is now being given away to the Wi-Fi use. So in the US, I think we are back to square one where we will not have a dedicated spectrum. I just want to mention, Bruce, when you say 5G, it's very important to understand that there are two kinds of communication, right? The up-down link and the side link, right? Most people use 5G because of the up-down link, right? You download a movie in 1 second, right? So that's 5G. Side link, we don't need a lot of capacity, and your target is other cars. So 5G or higher frequency communication needs better line of sight, right? If you're not in line of sight, your range dramatically reduced. So there are a lot of reasons, people don't really study the technical differences between the frequency, the interference and capacity and many other things, or real timeness, latency, and they just say, oh, 5G can do everything. That's absolutely not true. We think that even for CV2X, right, you will have a cellular phone tower communication, which is a up-down link. And then you also want a side link directly talking to other cars with or without a tower. So again, there are a lot of challenges and people just say, oh, 5G is the solution. That's absolutely a nonsense talk.
Yes,
yeah, if I could add a few words. When your question asking DSRC versus 5G, these two actually live together. I think that's what European approach, particularly the Volkswagen, they call it hybrid approach. DSRC could coexist with 5G. The other competing technology is a 4G LTE based. It's not 5G. It's I think a lot of people are not aware of that. Both DSRC and the other technology can coexist with 5G. In addition to that, I think there's certainly challenges on how many devices should be on the road to produce a good level of a benefit for the consumers. That's where the work Huei is doing in Mcity and a lot of deployment since 2012 in Ann Arbor is making I would say, a historically significant step towards a fully connected smart city. These in Ann Arbor, we probably have the world's most dense connected environment. I have a V2X vehicles in our office that we drive to Ann Arbor once a while. we can tell which cars we can communicate with. Like many of the UFM buses, we could see the buses coming. Once in a while, we would have a side collision alert triggered by the bus coming from the sideway. Those are telling there is early day benefit. And I think UFM is also part of a new project to populate more, we call the smart intersection, which Honda implemented we're adding more in Honda R&D Ohio area that has infrastructure with a bird's eye view to broadcast the road users information as if those cars and pedestrians has the V2X technology. As an early adopter, if you drive your V2X equipped vehicles, you can instantly see what the future looks like, a fully connected environment around that intersection. That's what I think these early deployment is bringing as a value. Until the vehicle density grow to a good amount, infrastructure play a very critical role.
Yes, and when I was looking at the story of 5G, and as Huei was saying, this line of sight story, where you had to have towers everywhere if you actually want to take advantage of 5G. And yet, Henry, you said that in China, 5G is the plan. Is that because they're just going to put towers everywhere?
So far, I think again, there's a lot of these from government investment, right? So just like high-speed rail, and they have been putting a lot of stations, 5G stations around the country, and then particularly in the big cities. Yeah. And whether 5G, one is for the consumer, right? 5G for the consumer. The other one is for the industry use of the 5G. I think in terms of the use cases, the number of use cases at the moment is still need further developed. And it's not sufficient yet. I still have a lot of rooms to develop new use cases. And automated driving is one of the use cases, potential use cases.
Right. And that's one of the questions I think that came up is in terms of legal or regulatory issues regarding accidents that might be caused by an ADAS system malfunctioning. Which party is going to be at fault? Huei, have you been looking at that issue?
Yeah, so for ADAS, driver is in charge, so it probably will still be handled by the current insurance arrangement. Yeah. It is so hard to distinguish whether that's the fault of the ADAS or the driver. And when it's the ADAS, what do you mean? Is it the sensor or is it the control and so forth? So I would say again, ADAS insurance likely will stay as what they are today. Yeah. Level 4 is totally, obviously, it is the obligation of the manufacturer of the vehicle that need to be responsible for the crashes.
And there will be ways of testing whether in a particular accident, did ADAS fail or was it really driver error, right?
There will be event data recorder. So today we have event data recorder, which captures the last few seconds of data, trying to figure out what happened. Going forward, for level 4 vehicles, the event data recorder will need to be much more detailed and much more data will be collected.
Okay. Very good. Yunmei, let's go to the next question. What kinds of services and technologies can be available to consumers when they're not driving? What data is made available or visible to consumers? This is more of the comfort and convenience story, right? Sue, do you want to start off on that?
Well, I actually would request a pass on this question. We're still working on the critical safety mission, so that's a little bit further than on my research plate.
So let me try to say a few words here. So some people actually jokingly say, Driving is unnecessary distraction from your life. So basically, they don't like to say, oh, driver got distracted. Actually, they say people got distracted because they need to drive. So level 4 vehicles make it possible for you to go back to your life. You want to work on your smartphone, your PC, and so forth. Get on with your life. Driving is taken care of by the robot. So in that sense, then it's just the way it is, right? You work on your smartphone, PC, and so forth. But of course, the vehicle need to tell you this is where you are, this is where you are going, and any information you worry about. Are you making the connection to the bus, to the airplane, to the train, and so forth? So all the information that's related to your life, your trip, need to be displayed very carefully. And people want to be informed. When they need to know, they need to know.
So, Wei, when you look at the level 4 story compared to the level 5 story, what becomes the difference between those two?
There won't be level 5 in a few decades,
Right.
if at all. So again,
But in a level 4
I don't believe in level 5. Level 5 means infinitely large operational design domain, and that doesn't exist.
Yeah.
When there's earthquake, when the volcano, when the road totally collapsed, do you still want to drive?
Yeah.
No, you have ODD. You always have ODD.
Okay. Henry, did you have anything you want to add to that story?
You mean the question or the outlaw?
The question. Yeah, the question.
The question. I wasn't sure what the question is on in terms of what the question means. The service to drivers. Is that the connectivity enabled service to the drivers, or what's the?
Yeah, does it? Yeah.
Okay. I think we talk about some of these already. I mean, with connectivity, there's a number of things that can be enabled, right? So a lot of these is related with interactions between the vehicles and the drivers, all the vehicles with the other road users, and connectivity can enable a number of these applications. For example, access to the car, and then messaging to the other road users in terms of what the vehicle's intent is, and things like that. And so there's a number of things you can do, and in fact, I think the connectivity will open the door for imaginations, for interactions between our services to drivers, passengers, road users.
Henry, you've got a project that's coming up that's going to do this connected vehicle slash autonomous vehicle connectivity between Ann Arbor and Detroit. Can you tell us a little bit about that project?
We have actually two different projects. So my project is what Sue mentioned a few minutes ago, which is called Smart Intersection Projects, and that's a project funded by USDOT, and we will instrument a network of intersections in the city of Ann Arbor with a set of infrastructure sensors, and basically to help to accelerate the deployment of connected automated vehicles, and that's essentially the goal of this project. So what we're looking at potential sensors at the infrastructure, and then with these sensors we can do the object detection and tracking at the intersection as well, and then we'll be able to utilize connectivity to broadcast information of the intersections, and then so that either the connected vehicle or automated vehicle with connectivity, they will be able to receive those and then utilize those for their own purposes. And as Sue mentioned, I think city of Ann Arbor is probably still the world most concentrated connected environment, and right now we have about 75 intersections with RSUs in most of the, I would say, in most of the intersections within the city of Ann Arbor. And then with this new project, this will enable us to install additional sensors, not only the connectivity to these intersections. And then as part of this project, also will instrument a few intersections with 5G, and so that they will have the new technology, communication technology as well. And so that's my smart intersection project, and that's a project will last about 3 years, and from this year to 2024. And when you say connecting Detroit to Ann Arbor, that's a totally different project, and that project, Huei and I also involved, and that's a project by Cavenue, by one of the subsidiaries of Alphabet, and they're looking at a dedicated lane connecting between Detroit and Ann Arbor, and that project is called Michigan Connected Corridor project.
Mm-hmm. And where are we in that progression of that development of that project?
You want to take that?
Yeah, it's mainly a project led by Cavenue, again, an Alphabet subsidiary, and MDOT, Michigan Department of Transportation. For the first 2 years, there won't be any construction. It's all about communication, outreach, design concept, planning. So you wouldn't see any real construction work starting at least until 2023. And it wasn't clear at all when any real work will start. So it is still much more a planning and paper study at this moment.
Yeah.
For another 2 years.
Yeah. But is it the state and the federal government that have supported this?
No federal government. Just it's a primarily a private investment, but of course Michigan being the place where they are designing this corridor, MDOT is heavily involved.
Yeah. So we'll see something maybe in 5 years.
I don't think I'm in the position of predicting that.
Yeah. Okay.
I can only say 2 years. It's mostly planning, paper study.
Okay. Very good. We spoke a little bit about government, so let's go to the next question, which is our government question. And what are the government and development and regulatory challenges? And here we can talk about both across all three domains, right? We could talk about the HMI story, the autonomous vehicle, and the connected vehicle. And what is the role of government between the U.S. and China for the connected vehicle? Do you see differences among those two countries and how they're approaching it? I think everybody has a little something they can say on this one, right?
All right, I'll start. I'm more familiar with the U.S. situation. I am very appreciative to U.S. DOT's funding and the support since 20-some years ago to design the V2X safety system after the spectrum was allocated. And we've made a tremendous progress. Ann Arbor was the world's first large connected vehicle deployment location in 2012, the safety pilot led by Jim Sayer and Umtree. And since then, there's a number of large deployment in the US. For example, the Tampa CV pilot, New York, there are several thousand yellow cabs in New York equipped with technology. And the most recent Ohio DOT's smart mobility corridor, where Honda is contributing hundreds of vehicles. I'm leading that project. We actually do have Honda employees driving their own vehicles retrofitted with this technology. None of these would have happened without the government strong support. However, on the other side, you also see FCC making a very controversial decisions that's hindering the deployment of this technology and reducing the spectrum. That's significant impact the technology rollout, because we're only seeing the day one usage of a basic safety communication. There are automation related, control related functions that needs a dedicated channel and much higher level of robustness, which would reside on a different side of the spectrum that's being taken away. So the government can be extremely efficient on one side, but then the other part of the government may not be as aligned. And then if we talk about automation, the state legislations right now are not aligned for automated operation. For automakers to deploy eyes-off systems, that these system needs to function seamlessly when the vehicle cross the state border. Right now, US is not there yet. And that's why we emphasize a lot of the Honda's effort to put in Japan to work with the regulatory agencies to change the law, basically saying now the driver is allowed to operate in-vehicle video devices when the vehicle is in level 3 mode. That's part of the certification process, which means the government are accommodating the automation features to allow eyes-off driving. It's a few line of revision changes, but it takes years of effort by industry and the government working together. And I think US certainly can learn a lot from the Japan deployment.
Very good, thank you. Huei, what is your view on this?
Yeah, maybe I can say a few words on the related to automated vehicles. So obviously, the U.S. government is taking more of a hands-off approach. The argument, two arguments, I think. Number one is government, especially U.S. DOT NHTSA, has the authority to govern anything related to safety, but they hesitate to come up with anything that's related to comfort and convenience. Therefore, even at this moment, there's no regulation per se related to level 1, level 2. They can test it as a 5-star, like an NCAP kind of thing, even though even today they don't have it. Europe has it, right? Europe has a very well-defined testing protocol for ADAS. China is working on that. In fact, if you look at the Beijing government, actually they published something testing related to automated vehicles. So in that regard, I would say Europe is leading, China is behind, US is even further behind in terms of automated vehicle regulation. Of course, the government is now thinking about, okay, if there is a level 4 vehicle from Waymo or cruise automation, they want to deploy on the roads, whether it's a shared fleet or not, I need to have some kind of testing because there may be a safety implication. So I think they start to worry about that. In China, it's very clear. Government say, I know I need to regulate. I'm still learning, but I think they will come out with some kind of regulation pretty soon for automated vehicles.
Henry, do you have anything on that?
Yeah, in terms of government role, I think I want to go back to say, we can't really just looking at the car industry. We have to look at this as a transportation system. We have to look at how these cars being utilized, whether it's connected or automated vehicles. So if you look at any of the transportation systems, there are three major components. One is on the vehicles, vehicle, and the other one is infrastructure, and then the road users. And so if you look at this from a system perspective, you obviously see government will play a very, very significant role on any one of those, right? So on the car, there's safety, assurance. There's also some of the things related with the use of the vehicle as well. And then you look at in terms of infrastructure, how the government has an even larger significant role in terms of investment, in terms of the standard setting and things like that. So so the government in the transportation technology, not only just the car technology development, it is absolutely critical, I think. And Sue mentioned 20 some years ago, the U.S. in the initialization in terms of the connected vehicle program, and you can actually see the progress of that program, the technology. I think starting at the very beginning, it was vehicle infrastructure integration or something like that, and then they become what is there was some drive. I forgot that there's a few names evolution until they get to the so-called IntelliDrive program, and then they evolve into the connected vehicle program. So there's in terms of the technology, even on the technology development, the government has a significant role, whether this is in the U.S. or in China. And then in terms of the differences between the U.S. government versus the Chinese government in the transportation domain, and I think I would agree with Huei. The only thing I would add to it is the Chinese government, the investment from the Chinese government on the infrastructure is very, very significant. And I would expect, or I hope that the new Biden administration also has a very significant infrastructure, bill or package, and so that we can make up some of our gaps in terms of the infrastructure investment.
Very good. I think that's all the questions that we have that we've designed. We do have some questions for the audience, but I think the organizers want people to fill out their review of the of the conference before we go on to the Q&A. One of the things I found out with my own conference is if I wait until the end of the conference, people are gone and they don't have a chance to. I mean, they never never fill out the survey about the conference. So please take a minute here to fill out the survey that the Michigan China Forum has put together for reviewing the conference.
So Bruce, I think I have a quick answer to right now the question on the very top. I think we talked about V2X already. So Julia Chen asked about pit maneuver. This is my personal view. You don't want the government to have that capability to stop vehicles, because once you have that, a hacker can do that too, right? So obviously having that backdoor is not a good idea.
So it doesn't exist. It doesn't. I thought she was making it sound like it does exist.
No, I don't think so.
Okay.
She was asking if a CAV can be remotely stopped by the officers, then it can be stopped by the hackers too.
Yeah.
We don't want that.
Yeah. Sue, there's a question for you here. What will be included in level 3 system, and how is it different from a Tesla autopilot or similar system existing?
Well, I can talk about the Honda level 3 system, which is designed for eyes-off driving in certain conditions. And when the vehicle sensed that the driver needs to take over control, it will alert driver with a good timeline. And if the driver does not react, the vehicle will gradually come to a full stop. That's probably different than some of the other level 3-ish system, which I don't think it exists except Honda. Honda's the world first OEM to deploy such system, and with a full certification from the government.
Okay. There's a question about towers, talking about towers. How could 5G, both technology-wise and infrastructure-wise, contribute to the autonomous driving implementation?
So fundamentally, obviously, we all know that more information helps with autonomous driving, but you don't want to rely on the cell towers. You want your function to work almost everywhere, right? So the ideal situation is that you are capable enough without the tower. If the tower can provide more information, you work even better, safer. And also the vehicle-to-vehicle communication better not go through the tower. It's more a direct communication. So again, that's the difference between up-down link and side link type of communication.
Yeah, yeah. I don't know what the satellite signal that that Joe is talking about. Have you guys seen that that signal that he's talking about, the SAPECE satellite signal? That's not I'm not familiar with that.
Me neither. So
okay, we'll go to the next one. And Henry, this is probably based on your experience with Didi. You learned that Didi started to make smart taxis. What's the future of this new model?
Oh, I think as far as I know, they have their first model deployed, manufactured already, and then being deployed in city of Changsha and then Xiamen already. And that model called D1. I think it was last November or December, and that's a vehicle manufactured by BYD, and it's a model co-developed by Didi and the BYD together. And so that's the D1, and they are in the process of developing D2. And I don't know when the D2 will be released, but the D1 is focused specific use cases because Didi has a lot of ride-hailing vehicles on their platform. So D1 is specifically developed for the ride-hailing purposes. Like I mentioned, the right-hand side door, it's a sliding door, and then the left-hand side is regular door, and then they have the other sort of devices on the vehicle to notify this is when the vehicle arrive, when the vehicle depart, and things like that to the user. So it's specific design for ride-hailing purposes, and the inside of the vehicle, in terms of the vehicle cabin, there's also purposely designed, and they have a larger leg space on the passenger seat. And so the D2, I think a lot of these is related with, as far as I know, a lot of these is related with automated feature of these vehicles. And then Didi also have a separate unit developing automated vehicle as well, and they hoping to integrate automated driving systems into their ride-hailing vehicles, the robot taxi as well. So that's I left the company about almost 2 years ago, so I don't know exactly what the the roadmap and the plan is, but that's what I hear.
Okay. How do those, and Huei, you could weigh in on this as well, the differences between what Cruise is doing? They're starting to do a taxi service in San Francisco, and what Waymo is doing with their taxi service in Phoenix. Do those differ from each other in any major way?
Yeah, so obviously, in terms of the how easy it is to drive in Phoenix compared with San Francisco is very different. Phoenix is a newly emerged city. The roads are typically straight, wide. They don't snow. They have very little rain. San Francisco, on the other hand, is an old city. A lot of roads are narrow and windy, a lot of people, a lot of bicyclists and so forth. So of course, when Cruise Automation was publishing their safety analysis for themselves, they basically argue, hey, we see many more times, different scenario, even up to say 60 times more of these challenging scenarios in San Francisco compared with Phoenix. So again, the ODD is very different because of the geolocation of where they do the testing. So obviously, again, testing in San Francisco is a lot harder than testing in Phoenix.
I saw some data recently that kind of compared some of the vehicles that are being tested by company, and that that Waymo and Cruise actually were doing very well in terms of the, I guess they were measuring when the driver had to take over, right? When were there situations? And they were going, extremely, very large number of miles before the driver had to take over. Are you surprised by that, Way?
I'm okay. So okay. So let me just say first. Maybe I can try to bring up a slide that will also help with the discussion.
Okay.
So here will be my. Okay. So. Okay, so here is actually the true number. California, every year they publish their so-called disengagement results. Disengagement means when the safety driver don't, or the monitor, a remote monitor feel it's not safe, they can disengage the robot. So the x-axis is the how many miles they test last year, 2020, and then y-axis is the number of disengagement. And the line, the blue line and the green line corresponding to 10,000 miles between disengagement and 100 miles. So you can see a huge difference between companies. And like you said, Waymo and Cruise are the top in terms of, they achieve roughly 30, 40,000 miles between disengagement. So for typical driver, that means 2.5 years. If we measure it, you drive 1,000 miles per month. So that's pretty good results. On the other hand, of course, there are also differences in how they treat disengagement. Some companies say, if I disengage, I disengage. But some companies say, if I disengage, I'll go back to do simulation. And if I say, okay, the driver doesn't need to disengage, but they are just being too conservative, then they wouldn't count that as a disengagement. So again, pure number doesn't, it's not a fair comparison company to company. However, it's fair to look at companies along the year. So if you compare Waymo 2020 versus 2019, it's a more fair comparison. So I want to make that very clear. So just compare them is not totally fair. But basically what they are saying is that they are tens of thousands of miles between disengagement. So again, am I surprised? Not really. So they have been working on this for many years. Waymo for what, 8 years?
Yeah.
So
I'm impressed.
You're
Driving
surprised?
to San Francisco and not having to disengage.
No. Waymo, most of Waymo is not San Francisco. It's
I know, but the
Mountain
cruise
View,
stuff is
Mountain View.
all San Francisco, right?
Sorry?
The
No.
cruise stuff is all San
They are California. So the Waymo number doesn't include the Phoenix number, but
Yeah.
most of the Waymo testing is in Mountain View, which is
Ah,
very different from San Francisco.
okay. All right. Very good. What other kind of questions we got? Oh, we're right at 11 o'clock. And I think that we've done our job today, guys and gals. Thank you very much, Sue and Wei and Henry. Thank you very much for the discussion. I hope our audience learned some stuff about the HMI and automated vehicle and connected vehicle that they didn't already know. And I know I learned a few things, so that's all. That's always a good thing. Yun Lee, you wanna close it out?
Sure. Again, thank you so much. What an insightful panel discussion. I feel smarter while sitting in this panel discussion in the past 2 hours. So I definitely learned something. And in the last minute, we just wanted to thank you all for your participation. I wanted to again remind you the next exciting panel is our business panel to discuss the tech giants and the antitrust reflections between the two large powers around the globe. The time is March 21st, which is tonight, the US time, and tomorrow morning, Beijing time. So here, the QR code for you to scan if you are interested. And this will be the end of our panel discussion in today's event. Thank you again for your participation. Thank you, Bruce. Thank you, Sue. Thank you, Dr. Pan and Dr. Liu, for your time. Really appreciate it.
Patrick, thank you. Bye-bye.
You're welcome.
Let me make a quick